Assalamu alaikum everyone. So we'll continue our discussion on theodolite traversing. So talking about traverse, so we discussed there are two types, closed and open traverses. And now we'll talk about some of the checks that we can apply for both the traverses. Although we have discussed the checks in closed traverse in detail, but let's just review them once again. The sum of interior angle should be equal to n minus 2 into 180. And the sum of exterior angle should be equal to n plus 2 into 180 degrees, where n is the number of sides of the traverse. And then there is another check that we can apply, that the algebraic sum of deflection angles should be equal to 360 degrees, considering right hand deflection to be positive and left hand deflection negative. So we discussed about the right hand deflection and the left hand deflection earlier. So that depends upon the direction of your survey or the projection of your survey. So based on that, the summation of deflection angles is equal to 360 degrees. And then we have that check that we used to apply in compass traversing, that the difference between the fore bearing and back bearing should be 180 degrees. So that is obviously if you have those bearings and working with either a prismatic compass or some added adjustment in your theodolite. And then the chaining of each line should be done twice along opposite directions. So this is one check for linear measurement, that if you do it in more number of times, then obviously the chances of error being there are reduced. But there are some other ways to check it, and we'll discuss about them later on. Now we didn't discuss about checks that we can apply in open traverse. So all the checks were for closed traverse. But now let's see this open traverse A, B, C, D, E, F. And one check that we can apply in open traverse is called as the tie line check or the cutoff line check. So basically what we do is that at the end of the work or midway, whenever, uh, you introduce two more lines in your open traverse. So basically those lines are not part of the traverse, but they are introduced at a later stage. So let's see this line AD and the line DF, which are not part of the traverse. Now, one, you have the whole measurements on paper, and then you plot them or lay them out in the field. So since you have the measurements on paper, the bearing of the line AD, and the distance of the line AD, and then you can go in the field and actually measure this distance AD and DF, and also measure the bearings of the two lines. And if they match with your calculations on paper, that means the check is working and your work is correct. Otherwise, there is some error somewhere and you'll have to redo some of the work. So this is how a cutoff line or a tie line can help you in figuring out if the work that you are proceeding with is actually correct or not. So in summary, in order to check if your traverse is plotted accurately or it needs some recomputations or balancing. So there are a number of steps that we have to follow. So first, you have to see that what is the sum of the interior angles and the exterior angles. So first we apply checks on the angles and then we apply checks on the linear measurements. So first we apply that check, and if the sum of the interior angles is not equal to n minus 1 to 180, then we calculate how much is the error in the sum, and then that sum is balanced in all the angles equally. So that's one way to do it. Similarly, if you're working with bearings, you can apply that check of forward bearing minus back bearing being equal to 180 degrees, and if it's not, then you can balance those bearings like the way we discussed before. But there is one other way to do it, that is by finding latitude and departure of survey lines. We'll discuss in a bit what that is, and adjusting the error in each survey line based on the length of the survey line. So the adjustment is done based on the length of the survey lines, and this method checks both angular and linear measurements. So basically now we have a method that we are going to discuss now that applies a check on both the angular measurements and the linear measurements, and then it can give you a couple of methods by which you can balance that error. So hence we use the term balancing a traverse, and this is very important. Whenever we set out a traverse, at the end of the day you need to make sure that your set out is correct geometrically. So based on this method that we're going to discuss now, you can see if it's correct or not. And if it is not, we'll also discuss some methods by which we can adjust those measurements or those angles so that the whole figure is accurate geometrically. So before we jump into that, first let's have a little discussion on latitude and longitude, what they represent, because the latitude and the departure follow the same basic concept. So if this is the Earth, this figure represents the Earth. So these lines that are not parallel to each other, but they converge at the north and the south, and they don't intersect each other. So these are the lines of longitude, and the other lines which are perpendicular to those are the lines of latitude. And this over here is the equator. And so when you cut through the lines of longitude, you get a figure like this, and when you cut through the lines of latitude, you get a figure like this. So another representation. Now, what we can do is we can locate any point on the surface of the Earth by using these latitudes and longitudes. So this is the beauty of it. So in order to understand that, let's first see the lines of latitude. So the lines of latitude run horizontally, and they are represented to be as zero at the equator. And above the equator, we have the northern hemisphere, and below the equator we have the southern hemisphere. So the line of latitude at the equator divides the Earth into two hemispheres, northern and southern. So the lines of latitude are numbered 0 degrees at the equator, and as you go above or below, the angle keeps on increasing or decreasing. So it's 0 at the equator, and if you go down or if you go up, the angle would keep on increasing such that it is 90 degrees at the south pole, and 90 degrees at the north pole and 90 degrees at the south pole as well. So let's see this earlier figure. So if this is where the angle is 0, so any point on the equator would have an angle of latitude of 0. And if you go above or below, then obviously the angle would keep on increasing until on any point which lies on this line, the angle of latitude would be equal to 190 degrees. And yeah, so the North Pole, it is at 90 degrees, and we represent it as north because it is in northern hemisphere. So just a representation. Similarly, the South Pole would be at 90 degrees south, and the equator is at 0 degrees, like we discussed. So the 45 degrees north line would be 45 degrees to the north of equator, and a line represented as, or a point represented as 45 degrees south would be at 45 degrees to the south of the equator. But that is just one coordinate. Now we need the other coordinate to complete the process, because on 30 degrees the point can lie anywhere. So for that we have the lines of longitude. So the lines of longitude are perpendicular to the lines of latitude, and they are represented as 0 degrees at the prime meridian, and they are useful in determining the time at different locations of the Earth. So those are represented in terms of how far the lines of longitude are or where that region lies. So similar to what we had in the case of latitude, northern and southern hemisphere. So now we have the eastern side of prime meridian and the western side of the prime meridian, and the lines of longitude are represented as 0 degrees at the prime meridian, and they increase on both sides, east and west. And similarly, in order to represent them, you need to write down either east or west with that representation. So the angles keep on increasing to the east and west, and you need to represent them with east or west in order to determine the direction of it.